using brew installed, Docker and everything gets put on your machine as well. So a couple of ways, but this is like the main prerequisite, right? You have to have this, otherwise nothing is going to work. It doesn't actually run. Yes?
If you installed it traditionally, would you have to go back to the Docker desktop, or did they rename the whole thing?
No, the whole thing is, yeah, it's the whole app gets installed. I installed it the same way and just keep updating it with Homebrew, and now it's called something new. But if you just go to docker.com, there's an easy way to get to it and find the downloads. So it's pretty straightforward. It's not very complicated. It just starts up, and then you have a Docker daemon running in the background, which allows you to then run the Docker command on the command line. So it's pretty straightforward, and they have tutorials to help you get started if you need it. Okay, so this bit of code is from a Docker file. So the second piece you're going to want to have for any Docker application is a Docker file. Docker file is a set of instructions that's going to tell you how to actually run the app and what gets built into your image. So there's a one main concept you want to know is the Docker image, which is a file that sits on your computer. It contains app files. It contains everything except an actual like OS. It has pretty much any distribution of Linux, any of the drivers you need to install, that kind of thing. So in this particular one, I have, you start with a base image. So in this one, I'm starting with a Node base image built on the Alpine Linux distribution. I'll talk a little bit more about this in a second, but there are thousands, hundreds of thousands of base images you can start with, whether it's just plain Linux, if you want Debian or Ubuntu, you can start with that, all the way to any kind of collection of directives you want. So there's a lot of different commands that you can run in this file. Some to get familiar with are run. Run is going to run a shell command, usually in bash. So for this example, I'm using apk update and then adding Postgres SQL, so I can use Postgres in my application, and it comes with then it's on the box itself. So that way I can run all the commands I need to. I then copy over the package JSON file, running npm install. Copy is one. It's going to copy files from your host machine to the image itself. And then the command is going to allow you to run a specific command when the image starts up. Yeah?
So the copy will copy all the files that are in the same directory where I start do the command line?
Yeah, so the first half of that is your host location. So as you see at the top, I switch my working directory in the image to user/app. So then I take everything from where the Docker file resides, which is just the dot or root directory, and I copy that over to my working directory with the other dot. So this so then this first copy, package.json, is specifically that file is getting copied over to the root directory or the user/app directory on the image. Now, one thing to remember, this image isn't doing anything, it's just being built, right? So this image doesn't actually do anything at first. It's just copying files, installing files, getting everything ready to go. And then it's going to build this piece, I just forgot the word. This artifact, sorry about that. So this artifact that allows you to run it later as a container, okay, using the Docker desktop application. So just keep in mind that everything that happens here is sort of static. It doesn't really do anything. It just builds it out. Okay. They can get pretty involved too. This is one for Couchbase. There's a whole lot of directives here that I don't really even know exactly. It sets up some arguments. It sets up environment variables, and then does an export command with a wget and changing permissions on some folders. It's exposing a whole bunch of different ports. I mean, it's got all kinds of stuff going on. And that's the beauty of the Docker file, is anything you want to do, like anything you would normally do to like a Linux machine, you do in here, and it's going to build that into your image. So the Docker store is where I find most of my base images. This is just, you go in and you search for something like Node, and it comes up with just multiple versions, different distros of Linux that you want to use, and that's kind of the place to start. So if you want to use something like Postgres, you go here, you search for it, you find the right base image to start from, and you can run it directly like that. Okay, so the next piece of tooling that you want to know about is Docker Compose. So this is a Docker Compose file, and what this is going to describe is the environment that you're actually going to work in during runtime. So while you have a Docker image, nothing happens until you run it. When you run Docker Compose, it will build out the image into a container and allow that to actually become a task. You can also do it on the command line with just Docker run and give it the image name. But I like this way because it allows me to connect all kinds of things easily, and it doesn't, there's a whole lot of tags to the Docker command that I can never remember, so this is my lazy way of making sure that works. So in this particular instance, we have two services. We have a web app, and anything in here overrides what's specified in the Docker file. So earlier you saw I had like npm start as my command. In this particular instance, it does npm run dev, right? So I don't want to do npm start on a development box. I want to do npm run dev because maybe it starts up testing or some other thing that I want to do during development that I wouldn't normally do on a production box. This also lets me specify volumes. So volumes is an important piece in Docker as well. It allows you to connect your host app to the container during runtime. So in this particular instance, I connect my current folder to the user/app. That way, if I change files, those two volumes talk to each other, and it automatically updates the source code on the container. The second one is a directive that allows me to build something onto the image and then not overwrite it at runtime. So if I did /, it would overwrite it with my local node folder and node modules folder, and there would be nothing in it. So there's a quick trick for you to kind of get around that.
If you're running Python,
yeah, you can do all the different things with your different language. The only ones I'm not really familiar with how to do everything are going to be like C# and Java, because I don't work in those a lot. But yeah, you can do any of these that you want to do with your
What you would do run?
Yeah,
Dev or server?
Well, it just depends on what you need to do. I mean, this is just one suggestion of how to do something, but there's literally, the nice thing is the flexibility in Compose and Docker and everything allows you to write this however you need it to be, so you can do it any way you want. And it's a trap that I even fall into, where I tell people, oh, do it this way, and it's like, no, you don't have to do it that way. You can do it literally any way you want. We're all intelligent human beings. We all know how to solution things. If you find a way that works for you, do it that way. It's just sort of a way to go about it. So yeah, if you're doing it with like Python, there's a Python image to start with. I did a Python example a couple of years ago, but it's been a while. But yeah, you can basically set up volumes to talk to the container while it's running, and you can do pretty much whatever you need to do just based off of writing the right command and directive up here. The documentation when you get started is your friend. There's a whole ton of just different directives that you have to look up, because it's just hard to commit them all to memory. So you will find yourself on the docker.com a lot looking at documentation. So I also set up ports. Ports, just like the volumes, the left side is the host, the right side is the container. So my app runs on 3000 in the container. I expose it on 3000. I can expose it on 8000, 2000, 20,000, it doesn't matter. Whatever I put on the left is just, I'm going to do localhost and then my port number that I set in. you set up environment variables here. You can also set up databases. So I have Postgres here as an image that pulls in that allows me to run Postgres without having to do all the lengthy setup. One thing I personally hate is setting up databases on my local machine, so Docker lets me get through that by just using an image. It sets it all up for me, and then I can figure out how to do it on the production side later if I need to, but this makes things for me so much easier because I just don't like doing it, so it's kind of my lazy way of getting around it. And you're also going to need source code, right? I mean, any Docker app has source code to it, right? So you're going to have that. And in this day and age, GitHub is one of the more popular ones, obviously. So you can share your code here, which allows you then to share with the rest of your team as well during development process. So let's talk a little bit about what that looks like. So I boil it down to 3 stages, and it's pretty simplistic because I know that it's never really 3. It's like 50 million, and everybody has a different version of how you need to go through things. But you're developing, you're integrating code, and then you're sending it to production, right? There's QA, there's staging, there's all kinds of testing and acceptance and all kinds of stuff that goes down through the middle of this that I don't want to get into explaining, but everybody's been there, and it's just, this is a nice way for me to sort of talk about it and boil it down to a bare minimum. So the first thing I do when I start developing is I'm going to create a basic Docker file. So just like you saw in the beginning, why do I call it basic? I'll show you the example in a second, but we'll go through that. But essentially I want to be able to run, build out and run an image as a container at some point that contains my source code and allows me to work with it. And then I'm going to build out my environment with Compose. That way I can just do Docker Compose up and it will stand up my environment. So this is the example that I'm going to come from at this point. So you'll notice there's a slight change here where I do as dev stage. And this is going to be the start of a multi-stage build. Okay, so Docker has the ability for you to run more than one build in a process in one file. So if I have underneath copy another from statement, it would start a new build of that process, and I can then move things over from one stage to the next. But for now, just doing development, all I really need are my files. I need to make sure I have my bin folder and my path, and I need to make sure npm is installed all my requirements. So it's pretty straightforward. And the nice thing about Docker is that every time you build out one of these, it caches layers. So each purple line there is a cached layer that gets set aside as a different image, so if nothing changes, it just blows right through that. So that way, if your package.json file never changes, it's not going to break the cache, and it should then not run npm install. Just kind of makes it easier, so you don't have to wait around for everything every single time. So then with my Docker Compose file, all I'm doing is building out a simple app. And that simple app, I'm going to send to the build the context, and the context is the local folder. And then I'm going to target the dev stage. So that in that multi-stage build, whenever I run it under development, I'm specifying a specific targeted stage in my build. That way, I can add additional build functions later, but it will still only build this for development. I specify my command here, I set up the same volumes, everything's kind of the same as the first one. I set up a specific environment variable, but this just makes it super simple. I do Docker Compose up, and I pass in the build argument. And what that'll do is every time I restart this, it will build it using the Docker file to make sure any changes to that Docker file get included. If you just do Docker Compose down, Docker Compose up, it'll keep the same image that you have on your system until you rebuild that image. There's mixed feedback I get on this, but I log directly into the running container because it's just easier for me to hop into the container Linux distro and get on the shell and do npm install right there, right? I mean, it's super simple for me. I can go in, and as opposed to updating the package JSON, I just let npm do its job and update it for me, and then it will install it. The only caveat to that is I have to make sure every time I shut it down to rebuild it, otherwise those npm modules don't make it into my image. So, but it's a quicker way for me to sort of build things as I go and develop quickly without having to constantly rebuild the image itself. The other piece is you have to clean up after yourself every once in a while. A lot of images get built up over time. I'll have like a long list of just images that are on my machine, and I've actually created aliases to make sure I can just remove my volumes, remove my containers, remove my images, just to go through and just wipe everything clean, because each image stays on your hard drive, and they build up over time, and then you find out one day that you have like no space. You're like, why? It's like, well, because you got a crap load of images here that take up 3 gigs. So it's real easy to forget and just kind of not use them, and then but they linger. So you want to clean up after yourself once in a while, just to keep your machine free of those leftover images. So what are some of the benefits to sort of working with Docker directly? Well, you can share your environment as code, right? With the Docker file, you know exactly what that's going to build out as. With the Docker Compose, you know exactly how the entire structure of the application gets built. You put that into your GitHub repo, you push that up, somebody else pulls it down, now they can run the exact same thing you have on their machine, right? And you don't have to go through time making sure the 2 machines are set up exactly the same, which helps decrease machine setup, right? Which is kind of a ongoing historic problem, I think, for developers, is getting each machine to be as consistent as possible and making sure all the configuration's set up right. And it can be a headache during development time if something isn't quite right and nobody knows why, and find out it's just because somebody has an older version of something and didn't update it, and it's kind of a pain in the butt. You can also customize your own builds, right? So you can customize these base images to be exactly your needs for your development project, right? You can create it to where each time you do this, the development project you start out with always has the same base, and it's pretty consistent. You don't have to think about it. You just view from, my specific base name. Docker Hub has a registry that allows you to push images up, and then if you specify that image name, if you don't have it locally, it'll download it from Docker Hub and put it right in, and you can start from that. So I've worked in a couple of shops where we had a very specific base that we always used, always went there first, pulled everything in, and had all the stuff we needed. In DevOps teams, some of the more good DevOps teams, they'll have their own specific image that has all the security baked in they want and all the right pieces to it. So you don't have to think about it, you just create a new one using that base. So, okay, so let's talk a bit about, am I going too fast? Everybody kind of following along? All right, continuous testing and integration. So let's talk about the middle section of this. Nice thing about testing and integration with Docker is that Docker is ephemeral. Everybody know what I mean by ephemeral? Generally, okay. There's at least one, so I'll say it. They're throwaway, right? I don't care about a Docker container getting ran. I can just shut it off, start it back up, and it's a clean image, right? So that allows me to test with a consistent image every time without having remnants from a previous test, right? I just destroy it, fire it back up, and it takes no time at all. Typically, it's going to be as similar or the exact same environment as the production one, because you're shipping an image that eventually just is what gets ran, right? So you're packaging everything up into this thing, you're pushing that thing out to production, that thing now runs. You don't have to rebuild anything or make it match or do anything like that. It's all the same kind of stuff. And then one trick I like to do is when you do Docker Compose up, it sets the project name to the folder you're in by default. So if you use -p or -- project name, you can specify a different project name and run the exact same application twice, right? So I'll have one application running the actual app, has its own set of databases, its own set of code, and set up the volume to my host, same as I normally would. And that allows me to edit those files and add data to that as much as I want. And then in the other project, my testing project, it can run tests that will preload with data, add data and tear it out, and it won't affect my development time because it's all on its own project doing its own thing with its own databases. But the nice thing is I connect both of them to my host files. So as I update my host files, both projects get the new set of files and we'll test on it, and you can then run it locally and that kind of thing. So it's just the ability for you to run multiple projects at the same time using the same base code, the same source code, but then you can do different things with different, for different use cases, so like testing. Okay, so let's talk a bit about deployment stuff. So this is a cloud build file, and there's a whole lot going on in here. It turns out it's a lot simpler than it appears. Although my line breaks are terrible, sorry about that. So the under the steps portion, that's going to be all the different things that cloud build will run. And when you're running things in a remote environment, you want to tell it exactly what it needs to do because it's basically a machine and it needs to have all the instruction. So the first thing it does is it will build my application and then tag it with a commit SHA. So essentially so under args, build is everything gets passed into Docker. I think it's just the Docker command. So this one in this case is Docker build, and then the -t is for tagging, and then the tag at the end is a variable that gets pulled in by when the build process happens. Then the second one, where the second name is, now it's going to do push, and it's going to push it out to Google Container Registry. So this image becomes an artifact, it gets pushed out to a registry, it gets stored there. And then the third one, I actually use Kubernetes, so I got kubectl, and it's updating to the latest version, and it will update Kubernetes automatically. So I put a trigger in, and I'll walk you through this at the end, I have a demo for it. But essentially it's the cloud build runs all these different steps in order. It matches it to when I push to master, and then it automatically updates my site just by pushing the images, and then the new image gets updated in the Kubernetes environment that I built. This is Circle CI. Circle CI is, I just finished a project using Circle CI. It's pretty good. You can do quite a bit with it. But it's also Docker based, so it allows you to kind of anything you can do in Docker, you can pretty much do here. You just have to use the right images. So like under test, it shows the specific image to use, and then you'll tell it which one to use, and it'll spin that one up and run your test just like you would locally. And then this one's from CodeShip. So CodeShip has two files, one that defines the services, and then one defines the steps. The services file looks a lot like a compose file, so it will be pretty familiar. But just like the other two, there's very specific things. You're usually filtering on some branch, and then it goes through and does all the different pieces you need it to do with specific steps in a specific order. And if it matches master, it'll deploy to production, that kind of stuff. So there's all kinds of different tools out there that allow you to do automated testing. GitLab has a great one. Talked to the guy last night. You can actually GitHub Actions now. You can do a lot of stuff just testing with GitHub Actions. I don't know if that's still in beta or if it's GA yet, but whenever it goes to GA, if it hasn't already, I highly recommend you look into that because you can actually build a lot of great stuff using that as well. So, and that's all. All these get you typically run off of some sort of GitHub commit hook. So it's just something that gets done for you. So when you're doing these external services, there's a few caveats that you have to know about. Remote testing is just hard, right? You're not there, you're not on the machine, so things fail a lot, right? And it can get really frustrating and really tedious. One of the things that you typically will hit is you have a local environment variable set. It's not set remotely, so it passes locally, but it fails remotely, right? So little things like that will definitely cause you to rip your hair out, but be prepared to commit to it, right? Because it's worth it. And it's also, I actually wrote it in a way that it's there's a double meaning, because you're not only are you going to commit to the process of setting up the continuous integration, but you also are going to have to recommit code a lot, because you're going to be doing a lot of fidgety testing and trial and error, especially with some of those config files. I mean, you'll think you have it, and you run it, it fails at like the last step, and then you fix that, and it's like, nope, still not working, nope, still not right, and then it's like you finally get it, but you took like 7 commits to get through it. It's just a pain in the butt. But once you get through all that and get past those initial steps, it runs pretty smooth, and it does everything you need it to do. But the automation part of this makes your life so much easier, so it's definitely important. So then at this point, we just want to deploy it to production, right? We're in the last stage. So here's the extra directives that I was talking about earlier that help us get from just doing development to the production stage. So I already have the dev stage at the top. This build stage, I think is terrible, and I think I built it wrong. Ignore it for now. There's probably a better way to do it. But what I'm doing is, from the first one, I am copying all the files over again, and then I am running npm run build. So now I'm taking and I'm minifying JavaScript, I'm creating a build folder, and I'm removing all of the extra development stuff and just making it production level. And then on the last one, I'm setting up an Nginx machine, and then from build stage, I copy over all of my build files into my HTML folder. I'm grabbing my Nginx config and I'm setting it to the default, and then that's my final build. So now I have a web host with a configuration file and build folders, and that's it, right? So my final image is much, much smaller because I don't have all my node modules in there. I don't have all my extra, cruft, from development, right? So it's all streamlined, and it gives me as small of an image, because when you're moving these things back and forth, you don't want to have a 10 gigabyte file to move back. If you can get it down to 1 or half a gig or however big it needs to be, smaller the better, right? Okay, so then deployments can be manual or automated. When you're integrating the code, the first thing you're trying to figure out is whether or not you want to push a button to deploy it, or you want to just deploy it when it goes to master. And with Docker, there's always there's an intermittent step of pushing this to a registry. It doesn't have to be, but typically you do. And those build artifacts get built up, and you can either deploy directly from that, or you can go and you can retag it as master later, or latest, or production, or however you want to do it. So your environment then can be under your control. If it's something pretty small and pretty easy, just automatically deploy it, right? The smoother the process is going from development to production, the better for everybody, and the more automated it is, the easier it gets. Obviously that's dangerous, and it takes a lot of convincing at some upper levels, but getting the code out there is just a good plan on many, and that's a totally different talk I've done, is just the benefits to it. But the nice thing is your environment is already built. It's in the image, it's ready to go. All you have to do is just push it out there. And then if you need all the databases and everything, you need Redis for caching, or you're using Hadoop for big data, whatever, right? Swarm or Kubernetes will allow you to set up orchestration, so then you can have all these different pieces running together at the same time. And then this one, you can get your app code can get swapped in and out while everything else stays running. You don't have to tear it down and build it back up. So this is sort of what the flow looks like. You code, that code gets pushed up into a source control management, which then sends it to a CI process. That CI process will communicate back to the source control management whether or not it's passed, right? So typically you'll see in a pull request, if it's passed all the tests from Circle CI and it has, that means it's safe to merge. You can do that. So that's how that communicates. And then it will test for some branch, whether it's master or staging or production, whatever you need it to be, it'll test for the branch. And if that branch matches, it will move it to production. And the CI puts out the image to the registry, and the production will pull the registry image in and deploy that. Okay, so that's kind of how everything works. So let me just do a quick demonstration with my app. I don't want to do that. Hang on. Okay, so I have a local host app called Dad Jokes, because full circle. So anyways, so I have that where on refresh it will, it needs to be running first. On refresh it will just bring back a new joke from an API. So the first thing I want to do is I want to get it started. So I want to do docker compose up. And I didn't do build. So let me show you how that works. Docker compose up. There it goes. Okay, so it's going to build the app. Now this is going to be like watching paint dry. Just deal with it. Sorry, it's just kind of how it is. We got 15 minutes, so. Unless it's just going to sit there and do nothing.
Can you take a question while we're waiting?
Yeah, we can take questions while this is going. Yeah, go ahead.
Can you speak to opinions of Docker Swarm versus Kubernetes for deployment?
Oh man, Kubernetes is built really well. There's a lot of great stuff to it. So the question, in case you didn't hear over here, is Docker Swarm versus Kubernetes. What's the difference? And like is one better than the other? I think Kubernetes is better for bigger projects. Does that make sense? So like, it's stable. There's a lot of really cool things to do it, but man, the overhead is huge.
It's more learning curve on Kubernetes.
It's pretty hard, right? There's a lot of pieces. Once you start using it, they become a little simpler. So if you notice, it's on like stage 6. Now it's starting to run. Docker Swarm is like, it's basically the same as a compose file. So there's not a whole lot of extra configuration. And you can just sort of push it out there and run it like that. Still takes some work to get Swarm to go. But if you're going to do like a major application, Kubernetes is eventually going to be the right way to go because it's just that much more robust and you can do way more with it, in my opinion. Both do a good job at just orchestration. It's just sort of the scalability of that big sort of application where Kubernetes is going to win every time. Okay, so now I have a development server running. So it did everything I needed it to do based off of our Docker file. And now I have my app running, but I want to change something. I want to add a title. And I think I want to switch, I'm not going to do too much here, but I'm going to switch these. There we go. Much better. Love that. Doesn't really matter. I just want to make sure you know that they're different, because here's the one I currently have deployed, which is just like the one I just had. And for anybody out there, forgive me for the flash of unstyled content. I don't really care that much about this app, so I didn't make it that big of a deal. Okay, so now I have some changes in here. So I'm going to run git status, git commit, update, adding title, changing colors. Okay, now here's my cloud build. I have a trigger in cloud build that shows how this kind of talks about what it's going to do. I have a cloud build configuration file it looks for. I'm triggering based on a specific type. You can also do it on tags, so if you want to do like release something, and I believe it will take, yeah, so you can do regex as well. That way if you have like, if you want to do a trigger on feature dash something something, right? Anything that says feature dash gets a build of its own and deploys to some sort of, you know, templated whatever, right, container process on Google. It'll do that, right, that kind of thing. So there's a couple of ways to do it, or you can just select specific branches. And basically I save that, and then in the history, you'll see that it's actually building, and it's running the same process that was ran locally. So if you were watching, you would have saw how it was, you know, doing the first 6 steps before into my development environment, but now it says I have 13. Right, so it's that's also going to take a minute. So anybody else have questions, so we can kind of let this go? And yes, sir.
Managing packages inside a container, what's the trade-off of doing it using your Docker file versus something like Puppet?
Oh, yeah. I mean, you can have Puppet run. I mean, okay, so I would be more of it. I don't know Puppet that well, but you can run it in a Docker file. You can have Puppet bring in Docker if you need to. There's all kinds of different ways to do it. So I know what you're, okay, so Puppet is going to allow me to, let's see if I remember how this, it's like Terraform too, right? Where it's similar, where it builds out like a remote environment. Yeah. And then it says set me up web host, set me up a SQL server, a Redis server, and a Kafka server. Okay. Certainly doable. What can you, would you be able to specify, like, use images in, like, with Puppet? Like, would it be able to deploy the same kind of thing? Because what I think what I've seen before is you can set up like a Docker host and then pull images over. I think the biggest benefit to Docker is using it in the development stage. So you can almost, if you don't want to deploy on Docker, you almost don't have to. But what I would suggest is being able to use, if anybody come from a time frame where you built like a Ubuntu VM with like different Ruby versions on it, PHP versions, that kind of stuff. Docker does the same thing. It just eliminates the hypervisor and the graphic interface and all that. So it's now you just have this tiny little image that has all the stuff set on it. So if anything, using it during the development process like that is great. And if you want to go to something like Puppet to then orchestrate setting up your servers and then deploying code that way without putting in an image, you can probably get away with that. That's probably not a big deal. And you can usually set up your compose file to match anything like Puppet would set up too. Okay, so this one, you see it's compiling. So now we get down here and it says it's successfully built, successfully tagged, and then it's running, updated the cluster. So these are all directives that you saw in that file from the cloudbuild.yaml file. Push done, that means my Kubernetes engine should be updated. But let me show you real quick how this worked. So when I wanted to deploy this, I set it up last night. I went into new container image. I went in, you can set up any one of these, but I went into class, is it here? No, I think I went here. Yeah, so this, I have a repository on GCR, so my container registry, and I have dad jokes there, which I was able to select. I specify where the Docker file is, but it's just default. I can add any environment variables, and then I hit continue, and it built everything out for me. So there was one minor step I had to do, which was add a load balancer, but they have a tutorial that walks you through that. So then once that gets set up, I now have all these different things, and then I have, finally, just like that, right? Automated, update, all I did was push to GitHub, everything else went on its own. So that, to me, as a workflow, is like huge, right? I mean, I don't have to think that hard, I just push things out. All the image does is it goes from my machine, gets built, pushed out to the registry, and then sucked into Kubernetes. So that's sort of the traveling process of a container and how it all works. So at that point, are there any other questions or any other thoughts or ideas or any of that make sense?
I have a question about, is it best practices to have, like, so if you have like different dependencies, you know, for testing, right?
Mm-hmm.
Like, and you want to use the same image throughout your entire cycle, is it, like, do you just have to have those test dependencies in your production image?
No, so that's where the like multi-stage builds come in, because you can get rid of those later and do like, you can set the environment to production and do an npm install with production environment set. It's also, you can do, so this is an extremely like rudimentary setup, right? I have one Docker file, I have one compose file. You can actually have multiple compose files, multiple Docker files, right? There's so many different ways you can set it up. So if you want to do like a Docker file for testing, you can specify in there what you need for testing and just make that all on its own. I typically, when I do it, like all my testing stuff's in my dev dependencies, so I install them all the same, whether it's dev or test, and then on production, I just make sure the production ones get pulled in and nothing else. So you can easily do like a Docker file .production and have exactly what goes into it. That way, there's so many ways to go about it and set them up that, yeah, you would never have to leave test remnants or anything like that in a production image. Anything else? Thank you so much for your time. I really appreciate you guys coming in and listening.